check coming in. Is everyone awake after lunch? Raise your hand if you're not a presenter. Okay, we have one. That's good. All questions? Oh, two. That's two people that can ask questions then. That's sure the rest of you are just doing your own thing. So, CNFs. Well, what is the CNF? So fundamentally, it's a VNF, but running in a container, running cloud native. And really, you know, I guess it's fair to say, I mean, we're here at KubeCon. KubeCon's all about container-based applications. You know, everybody a few years ago was talking about applications and VMs. Everyone's very excited by that. Now it's all containers, but it feels like the networking world's lagging a little bit. You know, we have VNFs, but CNFs are only just beginning to happen. So really what we're saying is, just as enterprise apps have moved away from VMware and OpenStack and moved into Kubernetes, can we do the same in the network? And by the network here, meaning kind of virtualized network functions that are things like, you know, virtualized firewalls, DPI, proxies, whatever else it might be, but something that's networky, that's running, you know, in a container or a VM, and how do we move those into containers? And then how do we, I guess more to the point, how do we then make it genuinely cloud native? So instead of just taking an existing VM and saying, well, you know, this VM runs on Linux, so hey, we'll just run it as a container and we'll still have, you know, maybe it's netconf yang to manage it through, you know, something like Sweetcomb, and it's still very much a monolith. How do we get beyond that and start being genuinely cloud native? And so, you know, what is it that cloud native brings us? And it's all this stuff that Kubernetes promises in terms of, you know, the life cycle management and the orchestration and these nice immutable deployments where you just keep applying stuff, and if it's already there, nothing happens, and if it isn't there, it spins up. And everything's generally built around much smaller footprints than, you know, we have in the VM world. So because we don't, you know, because each instance doesn't have to bring its own instance of the kernel, you're now just bringing the individual apps, which can be quite small. And if that's the case, then you probably want the things you're deploying to be small. And that's actually kind of an interesting one with VPP, and I haven't, we need to characterize this more, I think. But with VPP, the question is like, okay, so you run it in containers. Well, how much memory do you actually need for VPP itself? And not so much for the code, but for the data. You know, the classic thing of huge pages and it grabbing a whole ton of memory when it starts up. So I think it's something we've got to look at. And I've not had time to characterize how much memory that is. So for example, you know, if I run one VPP container on a host, or I run 10, like, you know, how does the memory footprint grow? And yeah, industry excitement. I mean, great. There's what? I should be able to count you quicker than that, given how few of you there are. There's 11 of us. No, 12 of us. Me, I'm 13, the video person. But when we're at KubeCon in one of the keynotes tomorrow, there will be, you know, thousands and thousands, and it's this huge thing with massive industry buzz. So we need to do better than we've done up to now, particularly in the container space where, you know, they're very much everything up to now has been the Linux kernel. Performance for networking has been a bit sucky, so we need to get better than that, but equally better than we've done in NFV. So let's get away from these big monolithic apps. And also, yeah, let's do everything in open source. And certainly with this project, you know, everything's up there in GitHub. You just clone it and away you go. And really, where we're positioning Ligato now is not so much as a platform as a framework, and saying, well, look, here's a framework and here's a bunch of components, and you can use that to do what you want as a developer. Because in the end, it's all about enabling other people to build really good CNFs. So this is the framework. So there's a whole bunch of solutions we've already developed. So for example, where all of this stuff started off was with virtualized CMTS, or cloud-native CMTS. There are the obvious things you can do in terms of firewalls and VPN gateways and stuff, and that's progressing nicely. But I know Ed's going to be talking, and Fred, about network service mesh, and you know, Ligato is a good fit for that. We have contd VPP, which is a CLI plugin for Kubernetes that uses Ligato. I'll mention that as I talk. But you know, the fundamental components that you end up with are Linux itself, VPP, and then this Ligato framework that provides the manageability on top of VPP. So here's the stack, and here's how it works. So yeah, down on the data plane, VPP, Linux, using DPDK drivers typically, but also some native drivers. And then we have agents, and it's all pluggable. The whole idea is that, if there's a piece of functionality in VPP or Linux that it can't currently control that you need, then you just add a plugin to do that. So, we can set up on Linux, we can just set up interfaces, IP table rules, etc., routes. Ditto on the VPP side, plus all the extra stuff we need. And so I was talking about IPsec earlier today, so we have all the capability there to integrate with strong Swan, which means we need to be able to push IPsec rules into the VPP forwarding plane. The KV scheduler is an interesting piece of code, which really where this came from. So initially the model was all about, is still all about, you're in the Kubernetes world, and the way that people tend to just pull everything together in Kubernetes is using etcd. So you'll have your master, the master node or nodes will define the policy. The policy then gets pushed out through a key value store, etcd, and the worker nodes pick that up. Now, the challenge, I guess, that you get to when you're configuring, say, a router, is that if you think about it, if you just use a key value store and you push individual rules through it, the problem you can sometimes come to is, this isn't a message bus where you see, okay, I got message 1, then message 2, then message 3. All you're doing is looking at the latest current state of the KV store. So what if last time you checked there were 3 things that weren't there and now they are there? You've now got to know what order to apply them in. Now, sometimes that's kind of obvious, like there's not much point putting an IP address on an interface until you've created that interface. And there's not much point having a route that points at an interface or an IP address until the interface or IP address is there. But there are cases that are more complex, and so that's where the KV scheduler comes in, that it knows what all the dependencies are between those bits of configuration. The only other way you could do this, I guess, would be if you abstracted your configuration entities high enough that they were sufficiently atomic that they wouldn't have dependencies on each other. But it turns out easier to do it this way. So that's something that came relatively recently. So the initial implementation, we didn't have that, and I guess we just found that we were handling so many special cases, it was easier to have a generic infrastructure that could manage all those dependencies. So yes, the data plane is VIDO VPP. And really, what we're talking about in terms of Ligato is the green bit, the data plane management. So the assumption is you're already getting your DPDK drivers or whatever for the NIC, and that you're running FIDO for the data plane. And so the agent, the core part of the agent is here. And just to talk about it quickly in terms of componentry, so you have this Go VPP, but not step too far. It's kind of cool, this, isn't it? The platform's black and so is the carpet. So if you're walking backwards, you could quite easily go over the edge. So Go VPP just wraps the entire VPP-C API. But of course, there's no sort of knowledge of what the semantics are at that point. You're just wrapping the API, and that's where you actually need to do the work in something like the VPP agent to understand, okay, what I'm actually doing is configuring a route, and then providing an API to that. Nothing to say, we were talking about Sweetcomb earlier. Well, I guess the way I see it is that the old world of netconf or restconf, it's funny to be talking about it as old, but that world with Yang works really well for physical hardware, works really well for VMs. I'm really much less convinced that it makes sense in a cloud-native world. And there's, I guess, a couple of reasons. One is that the cloud-native world already seems to have its own ways of doing things, like etcd. The other is more sort of philosophical in terms of if you break things down into smaller components, and if their footprint's lighter, you now start to see the world in a different way, where instead of saying, okay, I've got this big monolithic PE router, which I could perhaps virtualize. So, you can, in fact, the demo, if I make it work later, has a CSR 1000V, so a virtualized Cisco router that can do things like virtual routing functions on it. If you're doing VMs, that's a great way to look at the world. But when you move into containers, it's like, well, if the overhead of spinning up an extra instance is small enough, why wouldn't you just spin up more instances? So why would you multi-tenant within your virtual router? Why wouldn't you run single-tenant ones and just run a lot of instances? There are some caveats to that, I guess. The obvious one being, I mentioned already about VPP memory footprint. I guess the other thing with VPP is that because we typically put the NICs into polling mode so that we're driving, basically just in a poll loop looking for packets, that tends to kind of constrain what size your instances are. You probably want your instance to be the right size that it burns one or more CPU cores. So actually, some of that scale down to tiny things may be a little bit tricky. So you may still have a need to multi-tenant at the instant. But again, I think that's something we need to explore further. And maybe there's better ways we can schedule in VPP without completely reinventing the Linux scheduler. I don't know. So what do we use? Well, it's based on protobufs instead of Yang. Transport-wise, it's agnostic, which kind of Yang is now. It just wasn't when they started. It was all about netconf. Oh, and I've got those lovely timings again. And we can use any key value store. I mean, we map onto them, and typically we use etcd, and that's just say pushing config out asynchronously. We can go into, this is so annoying. Pause. Maybe if I hit the pause button, that'll stop happening. Yeah, we can hook into message buses like RabbitMQ or Kafka. The pause didn't work, did it? I'm going to shoot whoever gave me these slides. And of course, there's REST and gRPC as well. And it's all been coded in Go because that's, I guess, again, what the cloud-native world tends to use. So that in terms of layering, you've got VPP itself, you've got Go VPP, which I say is kind of just a wrapper on the VPP APIs, but it's still quite low level. Mention API versioning in, that's something that, and I guess this is where with Ligato and even the stuff I was mentioning earlier around IPsec, where I think we probably need to have a bit of a debate around what goes where, and I think I was chatting to Florin about this earlier, the sort of, if you look at it, the APIs in VPP are quite low level and tend to be almost like an exposure of internal APIs. And so they're quite tightly versioned, and we don't do a lot of checking of, is the parameter you're sending sensible? And so in a sense, you could say what Ligato is doing is giving you that more stable layer on top. But in order to do that, it has to be quite tightly coupled to VPP via this Go VPP API. And I guess in the end, maybe that's what we have to figure out is where is the right place to put a stable sort of incremental API that might, a bit like Yang models, something that might add new features but isn't going to change and break the existing ones. But yeah, protobuf models. I mentioned the KV scheduler, and that handles this ordering issue. So we have the dependency graph, and we know what order to make config changes in. Key point with the VPP agent is that we just package it up as a Docker container. We just run stuff as Kubernetes pods, so it makes life pretty easy from a Kubernetes deployment point of view. So the KV store, and this, you don't need to use this. You can use gRPC or REST. We have that compatibility layer, so we can use different KV stores. We typically use etcd, certainly in the Kubernetes cluster case. And you just watch for key values and watch certain keys to see what value you get for that. We have this concept of a microservice label, and the reason for that is if you think about this, what you want to do is have this one store but be able to have multiple VPP agents. So I mentioned earlier, for example, the CUPS architecture for IPsec. If you've got 10 different VPP instances running your IPsec, you need a way to distinguish them. And so that's where you do something like the microservice label to say, okay, I'm looking for changes to KickNOS 1, he's looking for changes to KickNOS 2, she's looking for changes to KickNOS 3, and we're all happy. And so this is really saying, where the KV scheduler came from, I guess, was realizing that, we were just dealing with so many special cases in handling config directly on VPP, and sort of the problems in VPP itself, where when you restart, are you in the same state you were in last time? And even if you apply the same config, unless you put it in the right order, you don't get the same results. There's a quote from one of my colleagues about stumbling upon the case where a configured VPP, after a restart, it looked exactly the same, but it wasn't working. So that's where the scheduling approach came from. And so really that's this layer, I guess, on top of the VPP agent that's basically handling getting those dependencies right. And fundamentally it then becomes the kind of core of what we're doing in the architecture, because everything's going through the scheduler to make sure things get applied in the right order. And again, configuring VPP and the Linux system, you get, so there's a certain sort of transaction thing in there as well where so for, classic thing would be that you're setting something up where you need a tap interface between Linux on one side and VPP on the other, and so you'll specify what they are, but it'll make sure that both of them get applied almost as one transaction through the agent. So either neither of them is going to be there or they'll both be there, which is the behavior you want. Now, Rasto could give us the details on this probably better than I could, and he's not in the room. So I'll probably skip over this one. Plugins, that's more important in general, which is that, it's essentially everything's done through plugins. So the basic skeleton of the Ligato infrastructure has pretty much nothing in it, and then everything comes in as plugins. And hence saying that's why defining it really is a framework. You can get the specs out of the docs, but the key point being that you can then target this or whatever your app is, so have the plugins you need for what you're doing. So where we're doing the IPsec stuff, we'll have a different set of plugins to what we have where we're doing contd VPP and we're acting as a CNI plugin for Kubernetes. So there will be some that are shared, but typically you have a different set. So yeah, written in Go, as is pretty much everything else in the Kubernetes world. Go, as you probably know, has some really great features around things like concurrency, which is always good fun when you're troubleshooting because of this, you spun up a thread to do something, or you're tracking, you've registered this thing and something's happening somewhere else and you're not quite sure which one's happening first. And yeah, anything with more than one thread going on at a time is fun. So yeah, core building block for CNFs, but we're kind of agnostic as to what those CNFs might be. So for example, the vSwitch, that was one of the first things we did. So back when we were doing the cloud native cable stuff, we based it around a vSwitch, and the main functionality there was to drive the NIC, but then also to implement VXLAN so that you could have like a cable data plane instance, which also runs in VPP as a CNF. But that data plane could be spun up with a fixed IP address, and then if you had to spin it up on a different server, it could keep the same IP address, and VXLAN would let you do that. And so that the external entities that were talking to this wouldn't have to be reprogrammed when things moved around. So we could kind of hide that under the covers. Now, initially, when we're doing stuff with cable, the vSwitch was just handling the data plane. And so for their management and control plane, they were using Kubernetes and they were using Flannel, I think. But the next thing we did was built this contd VPP, which is a CNI plugin for Kubernetes. And so contd VPP, effectively, you can share the same vSwitch. So choose whether you have separate vSwitches or an integrated one for data plane and for management. Network service mesh, I can see the network service mesh guys in the back row. Again, this is a perfect way to implement that. New CNF, someone mentioned the IPsec stuff this morning, and I could even hopefully get a demo to work now. Service function chaining. So this was quite early on, I guess. We saw that sort of the goal in a lot of cases, there's always been this sort of thing about service function chaining of, well, I don't just want a firewall, I'm going to want a firewall and DPI and a proxy and this set of things, and you need to put them in the right order. And those bloody timings have come up again. And so really it's just something we could let you do that, define what those functions are, then render them with an awareness of what your actual service topology is, but also Kubernetes knowing what your topology of nodes is, and then render that down into the network. Now, this was, I guess, also to the point that I mentioned earlier about the difference between doing stuff in VMs and containers, that where things are lighter weight. Why would you have VNFs and packets hopping between different servers? Why wouldn't you build a single tenant chain and try and restrict it to one node and just use memifs going typically, just straight between those functions? And again, either direct east to west or bouncing through the vSwitch if you want to get better sort of application of policy. But why wouldn't you do that rather than having these big monoliths? This was just to show, okay, this is how we would create the memif, and this is the equivalent CLI, so pretty trivial, really. But of course, all being done through APIs. Where you do want to go across nodes, typically today we use VXLAN. You just have a VNI for each different chain, and then in that case, again, you're just creating a VXLAN tunnel, but you're not creating a bridge domain that you're hooking multiple VXLAN tunnels into. You're just using a cross-connect with a VXLAN tunnel. So it's still just straight layer 2 interface type stuff. Contd VPP. So this I mentioned is the CNI plugin that uses Ligato. And so in this case, what was, I guess, most interesting with this implementation was that traditionally in most Kubernetes CNI plugins, the kube proxy is where all the cluster NAT happens, so the cluster IP that's basically your service address. So typically, for example, say you spin up 10 Nginx's, you want then one persistent address that maps to your Nginx, and you can have 10 replicas running on any one of your nodes, and replicas can come up and go down and whatever. And kube proxy handles all that, but the thing is that's in the kernel using IP tables or I think IPVS in the latest versions. So we then implemented that NAT in VPP. I mean, VPP had NAT already, of course, but added a few features there so that we could do a compatible NAT in VPP so that we would stay in the user plane. Now, where you have a pod that uses the host network, you'd still be using kube proxy, but generally your application pods are going to hook in to the contd vSwitch either through taps or where they're CNFs, you might be using memifs. Mention network service mesh. Keep mentioning network service mesh. I don't know if they're next to present or not, but we'll just keep mentioning network service mesh. There's a link to it. And again, this is something you could easily put on top of Ligato, but obviously, to be clear, something like network service mesh should be agnostic to the actual plumbing we choose to use. That they shouldn't have to be tied to doing it this way. The IPsec VPN KickNOS I mentioned earlier. Why don't I just, for giggles, try and do a demo? Because what could possibly go wrong? Here we have them. This is the problem. Everything just gets closed, right? And I've got to get onto that screen. Up. Why I've buried this down so many levels of hierarchy, I'm not sure. Let's see what we're running. Okay, we're not running anything. Of course, it would help if I could type, if I could spell. So just spinning up two pods, a KickNOS pod and an instance of etcd, just because we wanted to firewall this into its own etcd instance. Gave it a little while for the containers to start before I wrote all the things into etcd. So that's there. So now, I guess, if we do that same, that one. Yeah, we can see they're running, and they should be running on this node to the left, KickNOS 1A, because I've told it to run on that node. And this is kind of like what I was mentioning earlier about you might have QAT cards here and not there. In this case, it's just I didn't want to mess with somebody else's nodes because it's not my cluster. Right, so I have an ugly script too. This is the one where I think I mentioned earlier where I'm running on top of Calico, so I'm having to do all sorts of quite ugly masquerading of IP addresses and turning off RPF checks and things. So with a bit of luck, that's now running. That easier for myself. So it wouldn't be a demo without VPP actually running. Yeah, we seem to have an interface. This is the bit I forgot to do this morning. It didn't work. I forgot to put the secondary address on the interface, which is why it wasn't working. Which is dumb of me because it's just in the YAML file. Quit, isn't it, with this thing? Swancuttle. So that's to see if Swancuttle will tell us how it's configured. So it's waiting for somebody to connect. There's his IP address. I'm assuming the client isn't up. Yeah. Yeah, nothing much happening. Good. Right, so unshut that interface, which should bring it up. And you see, it's probably not going to run again because I've probably broken something else since it was working 5 minutes ago. I forgot to sacrifice the chicken. This is most embarrassing. That's extraordinary. This demo was literally working before I got up. So I score extra high for having 2 non-working demos in one day. I will make it work later, but do feel free to ask questions, like, why didn't you test your demo? Or anything else.